All right, welcome back, everyone. You know how it is. We have at least another 5 questions in 20 something minutes in this episode of the 5 and 20 podcast. I'm your host, Joshua Miller. And today we're diving into the dirty turned clean world of food waste sustainability with Hungry Giant Waste Systems, a company that's transforming how operations handle food waste management. With innovative technology, a unique service offering, and sustainability commitment, Hungry Giant is helping pave the way in this sizzling hot topic for the industry. I'm excited to introduce today's guest, Chris O'Brien, the founder and CEO of Hungry Giant Waste Systems. Originally from Australia, in 2017, Chris moved to Austin, Texas with his wife and daughters to attack this problem in a new and bigger market. To find out more about that, make sure you stick around to hear all the value that's going to be dropped in this episode. Great, Chris, welcome. Thank you for taking the time to join in on this episode and talk about your amazing solutions and give us more about your story. But before we go into all of that information, I want to know a little bit more about you. So to do that, I'm going to ask this question: if you weren't in food waste industry, what would do you think that you would be doing today?
Oh, I wish I got the advance on that question. I think I've always had an inquisitive nature. I've always been inventive. I've always viewed the world in a way that was like, hey, problem and solution. So I think I think I'd be inventing something or trying to solve some sort of problem. I don't think I could be too specific, but I think that's what I'd be doing.
Yeah, so still that the entrepreneur nature, probably innovation, like all that stuff. Love it. Thank you for taking the time here. So let's start with you giving us a brief background of yourself and Hungry Giant. You know, what inspired the creation of this solution? So tell us all about that.
Sure. Well, in my early 20s, I was studying. I was working part time in a big box retailer in Australia, and again, being that inventive kind of mind, I was seeing the amount of styrofoam going into the trash at that time,
Mm,
and I thought there's got to be a better way. This styrofoam weighs nothing, and it's taken up all this volume and space. And the company I was working for at the time had to get the dumpster collected, every day, sometimes twice a day. So I invented it. I invented, sorry, and built a prototype machine that turned the styrofoam into like a beanbag foam,
oh,
and it was an absolute disaster because it was just blowing everywhere, and it was a nightmare.
mm,
But that's how I sort of started in the waste industry. I invented this machine. I ended up refining the design. I commercialized it, and we sold that equipment to big box retailers throughout Australia. And so I was in the mindset of always volume reduction. How do we change the waste at the point where the waste is generated? Food waste is the holy grail of trash problems, in my opinion. So the next logical move, once we kind of built the styrofoam recycling business up, the next logical move was to tackle the big issue that was contaminating otherwise recyclable trash, which was food. And that's how I kind of went into food waste and started designing solutions for food waste.
nice, nice. So that kind of ties into the icebreaker question. You decided to go into this market, this industry, with inventing some solutions. So that's definitely awesome. So talk about in terms of Hungry Giant. Before we get into that, actually, I want to get into the generalization of what is Hungry Giant Waste Systems. What is it for someone that's never heard of it, doesn't know the company exists? What is Hungry Giant Waste Systems?
We're an equipment based solution provider, companies that generate food waste. So, commercial and industrial volumes of food waste. So, we don't really focus on residential or at home type equipment or solutions. That may change in the future, who knows? But for now, we provide businesses with equipment and technology to turn their food waste into a resource at the point where it's generated.
Okay, so would you consider that upcycling?
Would I consider it upcycling? I think so. I think converting a waste into a resource is a form of upcycling,
Hmm.
changing the composition of the material in terms of it being microbially active versus being inert and stabilized is sort of changing the state somewhat. And so it's using those raw ingredients or those waste byproducts to turn something into a resource. So I guess it could be considered upcycling, yes.
Okay, awesome. And so, with that said, there's obviously other alternatives that people are probably using. Most people, unfortunately, are probably going straight to a dumpster. Hopefully not. But in terms of, let's talk about composting because that's a term that people generally understand. Oh, composting, whether it's someone coming and taking raw material and taking it away. What is the difference in the process between someone that's just doing traditional composting versus what Hungry Giant is doing?
That's a really good question. So food degradation in general, it goes through a natural process in the environment. There's microbes involved. There is a natural breaking down of the food. There's anaerobic, which is in the absence of oxygen. There's processes that support anaerobic digestion. There's processes that are aerobic. And so if you have ever driven past a traditional compost operation or what they call a windrow, have you ever driven past one of those big places with huge piles of compost?
I have not.
I mean, they don't smell super fresh, but the process, to put it simply, is just big open areas of rotting food waste. They mix it with green waste, so they mix it with leaves and wood and browns,
Yep.
and other minerals and other bits and pieces all get mixed in the process, and then they turn it. They don't apply any heat. They're relying on Mother Nature to degrade the food waste and turn that into a compost material. So after a period of time, and that can vary depending on the material, but generally after a period of time, might be 30 days, might be 60 days, that material um, more commonly gets referred to as compost.
Yep.
And so that material has broken down. It still has a high nitrogen content or a high carbon content, and that material is microbially active. So it's not wet, but it can be kind of hot and moist to the touch. So if you've ever bought a
Yep.
bag of compost from Home Depot, or you've ever had compost delivered from a compost yard,
Yep.
um, if you let the pile sit there, it can get warm because of the microbes. So um, that's the traditional composting process that some of your listeners and watchers may understand. There are issues with composting. I mean, composting is necessary, but just generally speaking about the industry, you have a lot of cities and counties mandating that businesses have to recycle and separate their food waste for composting, and which is great. But what we're seeing is the infrastructure providers, so the composting companies that are building these facilities, they're almost at capacity before the facilities are built because they have such an influx of volume. And so,
Wow.
what we're finding, just generally speaking, is that you've got a lot of expansion in this space because of increased recovery of food. But what we're also seeing is more miles per pound, more emissions, because these facilities are getting pushed further and further out of metropolitan areas. And those metropolitan areas are key generation areas. So what we're seeing is a higher cost per pound. We're seeing more miles per pound, so more emissions per pound. And then the flip side of that too is I wouldn't say an oversupply, but an increased supply of compost material, which then affects commodity prices. So you've got an increased cost of processing,
Yeah.
increased cost of infrastructure, and then a decreased commodity value, which isn't good for the composters. You know.
Wow. You brought up some really good points there. Anything else on that topic?
Well, I think just to kind of delineate the difference between composting, where that industry is generally heading, and then versus what we tend to do, we're more focused on turning the food into a soil amendment by drying it out and dehydrating it. So at the point where the waste is generated, we are dehydrating the material, and what that does is it reduces those logistics component. It reduces the amount of methane gases that are emitted through windrows and composting. So our process is very different to composting, and I think they're both needed.
Yeah.
But one is more supportive of a hauling type model. Our offering is more supportive of reducing volume up to 90%, and then kind of focused on retaining the nutrient density in the material and then finding a way to have it reused. So sending that material back to farmers and ranchers and composters.
Nice. You definitely hit home on the emissions part of you're taking it from the facility and taking it to a compost facility. Like that's a lot of fuel being used to just move that food around again. So I actually laughed when you asked about a little bit when you talked about did I ever drive by one facility? I didn't, but I did experience something a little bit different. So I was at a campus, executive chef, and we had implemented composting. So they brought in these big, the trash can bins. We had them all lined up in the back, and the truck would come once a week. So you can imagine what it smelled like back there. They cleaned it, but even then, like it was just, it was great feeling for the environment, but the operational side of it, of having to smell that and deal with that, was not the great part. So
It's a big issue. Again, not to pitch or plug our technology too much, but that is a key benefit, is, to users, is that they're in control of the waste. So they dehydrate it, they process it. It can be stored for months and it doesn't continue to degrade because it's been stabilized. So that
nice.
odor issue, that urgency to get it collected, to get it hauled away, kind of dealt with.
Nice. So I think it's time that you walk us through a little bit of Hungry Giants technology. So people are hearing about it, how the process works. So really, let's walk us through some of the technology that you have and how it works.
All right. I thought I'd bring up these some visuals for people to see. But broadly speaking, we have two categories of equipment. The equipment on the left is a range of bio grinders. So we have essentially food waste shredders. It's like a large disposal if you have an incinerator or a disposal at home. It's a large version of that. This system centrifugally grinds the food and then it spins the water out. So what comes out of the machine on the left is essentially ground food waste with some water removed. So that machine on the left is like 50 to 60% volume reduction. So some restaurants, some cafes, they just have that equipment where they grind it, they reduce the volume, and it gets collected by their composter.
Nice.
The stuff that comes out is still wet to the touch. It's just not dripping in, with water or liquids.
Nice. That's a very unique system. I haven't seen anything like this before. It's usually just a one-stop shop, one option, but you're giving two options of what to do. You could do just to grind it, or you could do the grind it with the dry it.
Yeah, and you don't need both of those. You can have one or the other. So they are definitely complementary, because if you grind and dewater and you're reducing volume by 50 to 60% in a kitchen or a galley, that means that you can then put 50 to 60% more food waste into the dehydrator. So you're getting efficiency by having both. Some places want that if they have enough volume. Some places don't have enough volume and they just want the dehydrator, or they just want the grinder. So we have two offerings to try. In any kind of commercial environment, we have a solution for a kitchen.
And let's talk about why is it important that it's reducing the volume for someone that might not understand. Why do I care about reducing the volume of and taking the water out of food products?
Well, 60 to 70% of composting costs or hauling costs are to do with the hauling and the transportation. So if you're taking volume out of the waste at the point where it's generated, then you've got that efficiency gain straight away. In the context of what we do, taking volume out of the food using the biogrinder on the left means that you can fit more waste in a dehydrator. And because the dehydrator is drying out the moisture contained within the food waste, if we're mechanically dewatering it and then putting a partially dewatered material into the dehydrator to finish the process, then you're getting shorter cycles as well. So there's energy savings there.
Awesome. Love it. Love it.
You mentioned before that this was a unique product and you hadn't seen anything like it before. I'm proud to hear you say that, because I've seen other grinders. I saw other grinders on the market. They're a lot bigger, a lot more cumbersome, and they don't take a fairly comprehensive mix of waste. They can't take bones. They can't take shells. They can only take certain types of waste, otherwise they block up. So we designed this machine to take most waste. There's still some exceptions. You can't put large femur, like large bones in there, obviously. You can't put anything super stringy, like corn husks can wrap around certain components. But for the most part, most waste goes in, most mixed waste goes in. And the other thing is, um, every machine has recirculating water as well. So the water that we squeeze off or separate from the pulp gets recirculated. So we're using about 1/6 of the water consumption of a traditional industrial slash commercial pulping system.
Wow.
So
Nice.
it's a pretty cool bit of gear.
That is very unique. Yeah, I there's other solutions that it's like I thought that they were great because of obviously it's diverting waste from the landfill, but when you think about some of the like the water that they add in some of their solutions, it's like, but what are we doing? we're we're powering water and recirculating it all day like 24/7, or we're adding a bunch of clean water. So this is very cool in that it's not doing that.
Yeah, so our system does use some clean water. It has to do that because when you're recirculating some of the water from fruits and vegetables and meats, it can get quite thick. So
Okay,
we have to use some water for the grinding process to manage the viscosity of the recirculating water.
gotcha.
Um, but in general, we're using 1/6 of the amount of water just by way of design. So we have a little buffer tank at the back that collects the water and recirculates it. Um,
Nice.
we can jump through this slide. This slide just shows different configurations. We've got the standalone system that you see and that you saw on the previous slide, and then we've got like transfer systems. So if you have, for example, a commercial kitchen over here, but you have a loading dock over here or a trash room, we can automate the transfer of the pulped material. So you can have a system installed in the kitchen and it can be integrated into your dish line, or it can be in a corner or wherever you want to put it in a kitchen. And then we can install some pipes that run the material out to a centralized dewatering unit. So that can basically automate the transfer of the food waste to an outside loading dock or a trash room without having to manually take those bins out.
Nice. Okay, so and this is what another thing that I love, because you say up to 8 bio grinders can be connected to one central dewatering unit, which is that's impressive compared to other systems that say, yeah, we can connect, but it's like one or two. But in a larger facility, you need more than that.
Right.
So this is giving a lot more options for that. So how is it getting it from A to B? Is it using vacuum? Is it using water? Like, how is it getting that product transferred?
Great question. So the unit you see on the left there, that's the one that we saw in the previous slide. That one's grinding and dewatering all in one place. So you
Yep.
just get the bin that has the pulp. So that's the kind of the manual version.
Mm-hmm.
The one in the middle uses an impeller pump, and that also has recirculating water. So what we're doing is we're grinding,
Yep.
we're sending the pulp with the water because the water acts as a lubricant in the pipes. So
Mm-hmm.
we're sending the waste with the water to the centralized dewatering unit, and that's a 1-to-1 ratio in the middle. That uses an impeller pump system, and then it dewaters just above the trash can. It dewaters the food waste, sends that water back to the machine for reuse, and then the pulp falls into the trash can.
Nice.
The one on the right, the multi transfer, that one's up to 8 grinders per centralized dewatering system. We have lobe pumps that we use, so um, we don't use the impeller pumps. We use a different type of pump called a lobe pump and
Okay.
some vacuum. And then there's some really smart control gear with valves and solenoids that actuate between different grinders. So if you're say you've got in this picture here, you've got three pulpers or
Yeah.
three bio grinders. The control system centrally controls which valves open up and when. So if you're processing, it'll allow you to do a single cycle, which is under a minute, and then it'll queue the next one according to who's in that order. So it'll control the process so it doesn't lose pump pressure.
Nice. And I gotta say, I love the name Chewy here. I don't know why it's drawing me in.
Well, I can't take credit for that. It was one of our major accounts, one of our cruise line customers. Um, they named it Chewy, and I'm like, that's a great name. I'm going to use that. Can I use it? And they're like, you can use it. So then we updated all of our marketing.
Nice. Love it.
So this slide just quickly shows the volume reduction from the starting volume after we've ground it in the middle, and then after dehydration. So you started off, with 70 pounds
Yeah,
of waste.
that's
We ended up
insane.
with 6. Yeah.
That's yeah. Picture says a lot more, right? Yeah, it's 1,000 words. Is that the saying? Picture says 1,000 words. I
Yes.
think. Yeah,
Yes.
that is a moneymaker right there. In multiple ways.
Yeah. I think that,
Wow. And so let's talk about time. So in this example here, 70 pounds, then to roughly 30 to six. Like, how much time does it take to achieve those results there?
so the first stage of grinding, that's probably 10 minutes. Um,
Nice. That's
so
fast.
grinding. So after grinding is probably 10 minutes. That's an instant mechanical process, you know. So
Yeah.
you're feeding it in, it's shredding it, it's separating the water and the juices and whatnot, and then you've got the material that falls into the Slim Jim that you see underneath the grinder. That's about 10 minutes, and then you load that into the dehydrator. The dehydrator cycle time varies depending on the moisture content. So we have moisture sensors in the drum that sense how wet the material is, and it
Mm-hmm.
runs until the material's dry. So it could be anywhere from 5 hours to 17 hours, depending on the size of machine, depending on, up to 24 hours, even if it's really wet.
Yeah, that's still impressive. I mean, that is still very impressive numbers.
And, I always kind of say anecdotally that, we're doing what Mother Nature does in 12 weeks, we're doing that in 12 hours. So you're focusing mostly on volume reduction and efficiencies gained from volume reduction.
Yeah.
And then the beautiful thing about the output material too is that it's not just destined for compost
Mm.
because we've stabilized it. It actually opens itself up to multiple reuse options versus, um, you know, if you collect food waste and you send it to a windrow, then it's only going to be compost
Yeah.
because
So
that's what it is. So, we can use our material as, in energy from waste because it has a high calorific value, high burn value. We have some ships that dehydrate the material and they use it in their gasifiers and incinerators. And then they use that as a heat exchange. So, they're getting efficiency from that. We've got customers that turn this material into pet food, if they've got a controlled input. And this is just the beginning too. Like this industry, it's still very young and it's still growing. And it's great to be, kind of on that trajectory.
for sure. And I see a huge marketing opportunity here, right? So they're making this product, this post-consumer product, and or sometimes pre-consumer, but they're making this end product, and it's like, how cool would it be? I just think about like springtime when you drive by all these like home improvement stores and they have all these pallets of everything you need for your garden, all this mulch, all this soil, all the compost, like just pallets and pallets and pallets. How cool would it be for an organization to be like, look, we have our own thing that you can take home and you can add to your gardens and your landscapes. I think that's another great marketing opportunity and community engagement opportunity here.
Yeah, totally. Somewhere in this presentation, there's couple of slides on what we've called plate to farm. I think it
Oh,
might be
let's
late.
talk about that.
We'll go back to we can zip back and forward depending on where we want to go. But plate to farm is essentially what you're talking about. There it is.
Love
So
it.
plate to farm's a program that we're piloting at the moment, where essentially it's linking up farmers, ranchers, composters at the back end to close
Mm,
that loop. And the aim would be that once we have a critical mass, so a decent volume of material consolidated, that you can then turn that into a value added product. And who knows, it might end up on a pallet in Home Depot. I mean, I think that would be, as you said, a wonderful story and a wonderful marketing opportunity for brands. If you picture, every Starbucks has its coffee grounds dehydrated, turned into a product, and it ends up back on a shelf somewhere.
yeah.
That's going to drive a lot of consumer gratification. It's going to drive brand loyalty for these companies, and it's a true closing of the loop. And it's not just relegating anything organic to compost only. It can be turned into other things, which is super exciting.
Love it. Love it. All right. So let's talk about the bio dehydrator a little bit more.
Great. So the biodehydrator, the name says it all. It's drying out the food waste, turning it into a stabilized biomass. So the operating principle of the system is we have a drum and we have a whole range of sizes from 70 pounds up to 3,000 pounds input
Mm-hmm.
capacity. And we are applying heat to the bottom of the drum, the bottom half, using an oil jacket, and then we're recirculating hot air as well. So it's kind of like an oven. There's conduction, convection going on, and then what we're essentially doing is we're extracting steam off the process, and we are condensing that steam. So the only wastewater that comes out of the back of the dehydrator is a clear condensate. So there's no solids going down the drain from the dehydrator. Um, these are a batch cycle system. So you fill them up, you close it like an appliance, like a dishwasher. You fill it up, close the lid, turn it on, walk away. So there's no microbes, there's no additives. You don't have to balance your browns. You don't have to add any kind of consumables. It's just an appliance that you turn on and walk away. And so what happens is throughout the process, we've got moisture sensors in the drum that are monitoring the moisture level. And then once we reach an optimum level of dehydration, the system then commences a cool down sequence. And then the next morning when they come in, they just discharge it and start again.
Nice. And so you talked about the heat. So let's go a little bit more into detail in that. So like what temperature are we talking about inside? Like it's not an oven, obviously. So it's not like 350 degrees Fahrenheit. So what temperature is it aiming for in there?
So we've got a couple of different systems. The standard dehydration system operates at around 185. So we're operating above thermophilic levels. We're kind of killing off any activity for pathogenic activity and whatnot. So it's good in the sense that where we differ to other technologies that are available on site, there are other equipment that are liquefying and sending the stuff down the drain, which they call digesters. There are actual in-vessel composting systems that require a microbial activity, and they have their place and they're wonderful pieces of technology. They're just not for everyone in the sense that people don't want to bake it. It's like baking a cake. You've got to make sure everything's right. You've got to be feeding it constantly. You've got to make sure that everything's in balance. And so this system, I guess, is a little bit different in the sense that there's no additives, and you fill the food waste, fill the food waste up, turn it on, and kind of walk away. So yeah.
No learning curve, minimal learning curve, right? So you don't have to add anything like you said. So turn it on, walk away.
Exactly. Yep.
Awesome. All right. So that is all amazing information. And I wish that we had more time to keep talking more on this. But as always, we all great episodes. We leave people wanting more. And I think we did a great job of that in this episode. And so, with that said, one question I'm going to try to fit in here, which is what is the future of food waste management and how is Hungry Giant preparing for it?
Well, I think food waste management is a multifaceted thing. I don't think our technology is the be all end all for everyone. I think it
Yeah.
has application in certain customers, but it's a mixture. I think there's the hauling model and composting where it makes sense.
Hmm.
There's people that are commoditizing the material in a more of a decentralized model. There is prevention as well. A lot of companies that we're talking to
Absolutely.
are talking about how they can optimize their supply chain, how they order their food, and how they can make sure that they minimize waste. And then, of the waste that they have, what recipes can they create to utilize some leftovers and whatnot? So I think it's a multifaceted approach.
For sure.
We're kind of gearing up for. The trending increase on hauling and logistics, and focusing on that volume reduction as our main advantage, and then turning that into a commodity that people can then have multiple options for reuse rather than just compost.
Love it. And I totally agree. It can't be a solution for everyone, but thank you for what you're doing to contribute to this in our industry. And so obviously like I said, people may want to learn more. So where can listeners go if they want to learn more about Hungry Giant or if they want to connect with you?
Yeah, they can go to our website, hungrygiant.com. All of our contact details are on there. Fill out a form, call us, send smoke signals, whatever you need, we'll reach out.
Absolutely, absolutely. Well, thank you again, Chris, for everything that you're doing and your team. And with this, I have nothing but utmost confidence that this is going to continue to be a great solution for the market and growing for us. So thank you again. And for all my listeners, thank you again for tuning in for another episode. Until next time, I'm your host, signing off.